Hello, my Algebra 2 students. Today should be a pretty easy day. We are multiplying polynomials. So nothing really new here, just more review. So the very first thing we're going to talk about is the fact that there's two different methods to multiplying polynomials, at least specifically for binomials. So if we have as example number 1, let's say 2x plus 3 times x minus 8. All right, one method is to use box multiplication. And so in that case, we can put like 2x plus 3 up top, and maybe x minus 8 down the side, however quite you want to show it. And then you're just multiplying all the way through. This should be stuff that seems pretty darn familiar with you. So like 2x squared and plus 3x. And really, I'll move that minus 8 down here so I don't lose it. A minus 16x and then minus 24. So that we can combine our like terms here and come all the way out with 2x squared minus 13x minus 24. The other option that some of you may know, some of you may not, is FOIL, which is just the acronym, for first, outside, inside, last, or basically it's double distribution. And so in that case, if we just go through and show it, when we have 2x plus 3 and then times x minus 8, so we'll stick with that same problem. We do the first of each, so 2x times x, there's that 2x squared. The outsides, so the 2x times negative 8, so there's the minus 16. The insides, that's the plus 3x. And then the last in each parenthesis, that's the minus 24, which will inevitably get us down to that same answer when we combine those middle two terms, right? It does not matter to me which way you go about it. Just make sure that you have an efficient method to get to your answer. So we're just going to do a few examples together in the notes. So since we already hit binomial times binomial, let's do next trinomial times a binomial. Right? And so as I say it that way, but I might write it a little different in a moment. Trinomial, so three terms. We've got x squared minus 4x plus 4, and then times the binomial x plus 3. Right? I tend to like whatever is the smaller polynomial on the left, but it does not actually matter. So down the left side, I'm going to do x and then plus 3 here. And then along the top, x squared minus 4x plus 4. I do think box multiplication is a smart way to go in this case, just because with so many terms to multiply together, then we don't miss anything. So x cubed minus 4x squared plus 4x plus 3x squared minus 12x and plus 12. And then you're just combining any like terms that we can. So always write your answer in standard form, so highest exponent to least. So we can combine these guys. That'll give us a minus 1x squared. We can combine these two for minus 8x and then plus 12. Ta-da! All right, let's step it up a notch. The next one, I'm going to slide this paper here a moment. Let's go with trinomial times trinomial. The good thing is the process doesn't change any. It's just a matter of keeping things organized. At this point, no, you wouldn't call it foiling. I'm not exactly sure what acronym would happen, but it does get a lot trickier to keep track of all those terms if you're not using box method. So let's try it. We've got x squared plus 3x plus 1, and then times x squared minus 5x plus 2. So if we set it up, I'm going to take that x squared plus 3x plus 1 go down the side and take x squared minus 5x plus 2 along the top. Of course, it does not matter which one goes where. All right, if we're multiplying our way through, x squared times x squared, you're adding those exponents. So that's x to the fourth minus 5x cubed plus 2x squared plus 3x cubed minus 15x squared and plus 6x. And then finally, plus x squared minus 5x and plus 2. So if we put all of that together, we should have x to the fourth. These guys are going to combine. Oops. And I forgot I have my nice white out somewhere, but I'm not seeing it at the moment. So we'll just pretend we don't see that plus. So minus 2x cubed. We can put all three of these terms here. So plus x squared minus 15. So don't forget there's a little 1 there if it helps. So that's going to give us minus 12x squared. And then we got this term down here. So plus a single x and then plus 2. All right. Whew. Box all that in and call it a day. All right, the last thing we have to talk about in these notes is just the concept of an identity. So with an identity, I'm going to flip right to the next page just so I have more space. If you still have space in your notes, you keep on rolling. Identities are a mathematical expression that's always true. And really always true regardless of the value of like x or y. Right? So we'll do one quick one and then we'll save one for class for tomorrow. All right. So if I give you the identity that x squared minus a squared is always equal to x minus a times x plus a, you might actually recognize that as being the rule for difference of perfect squares. So a nice factoring rule, but it's an identity because if we take this product, it'll always equal this. So to be able to verify the identity, right, what we actually do is either factor down one side or more likely you'll multiply out one side to show that the two sides are equivalent. So the idea is to verify an identity. I'm going to say multiply out one side to show both sides are equivalent. All right. And so in this case, because we talked about FOIL, let's quick practice it. So on the right-hand side, let's go. First, there's our x squared. Outsides, that'll give me a positive a times x. Insides would give me a minus a times x. And then last would give me a minus a squared. That plus ax and minus ax always cancels. And you're left with exactly what you had on the left side. And so we just bring this on down. And we put a little check mark to say like, yay, we did it, right? So